Welcome to our educational channel. From class 7th mathematics, the second chapter is rational numbers. Okay, chapter 1 we already discussed about the integers, and compared to the integers, what is the difference in these rational numbers? Let us see using these topics. So these are the topics I'll explain here. Let us see exactly what is the rational number, how to define, and rational numbers and its properties. Then how to representation of rational number on the number line. So integers we already done representation on number line. Let us solve same way rational numbers on number line, and comparing rational numbers like less than, greater than, equal, the comparing between the rational numbers. And next, addition, subtraction, multiplication and division of all these rational numbers. All the mathematical operations like addition, subtraction, multiplication and division of rational numbers also we will see one by one clearly. First, when you come to these rational numbers, already, for example, if a and b are the integers, because as we know discussed the previous topic, if a and b are integers is all the negative and positive numbers along with 0, right? Then already we know that a plus b is also integer, a minus b is an integer, and a into b is integer. These three also is integers, but a divided by b or b divided by a, it may not be integer always. Okay, so let us take one small example. In the place of a, let a is equals to 6 and b is equals to 5. Okay, 6 and 5. So 6 plus 5 is 11. So 11 is an integer, right? And a minus b, 6 minus 5. So 1. 1 is an integer. And 6 into 5, 30 is also integer. But when you come to a divided by b or b by b, so okay, 6 divided by 5 or 5 divided by 6. No more we can cancel. So these are not integers. Now these come under rational numbers. So like a p by q form. So let us clearly discuss about these rational numbers. That means the fractions are said to be in the form of system of rational numbers like p by q form, and q is non-zero. Here a and b both are integers place. So exactly the rational numbers and its properties one by one discuss along with the definition. Rational numbers and its properties. To solve any type of problems in this chapter from any question in this exercise, we need to know the definition of this rational number clearly and what are its properties. Then we can answer anything. Okay, let us see the thing clearly one by one. First, when you come to this rational number, how to define? If p is an integer, let it be p is an integer. Integers already we discussed previous, right? Okay, p is an integer and q is another number, is an integer. This was an integer, and here is the rule is q is not equal to 0. Q is non-zero. So then the number of the form p by q form, so is called, this is called a rational number. This way we can define. So this is a definition about these rational numbers. So let us see the example. P and q must be integer. Q is non-zero. Okay. 2 is an integer and 3 also integers. So then 2 by 3 is a rational number. Even minus 6 is an integer, right? And minus 5 is an integer. So then minus 6 divided by minus 5. So is also a rational number. This all belongs to rational numbers. So is rational number. Say minus 6 by minus 5 is rational number. Just only observe these two numbers, the numerator and denominator must be integers, and denominator is non-zero except 0 any other number other than 0. So this is the thing. And when it come to these negatives, for example minus 6 by minus 5, or even we can take minus 4 by 7, okay, minus 12 by 5, 8 by minus 9, even in this order also we can consider as rational numbers like 3 by 4, positive, negative. Negative number is on numerator or denominator also is negative only. Both are negatives, numerator place and denominator place only become positive. Let us see in the properties. Okay, so this is the definition. When you come to this basic properties on this, first one, just remember every integer is a rational number, but converse is not true. Every integer is a rational number. That means let us take number 5. 5 is a rational number because 5 I can write, 5 is an integer. 5 I can write 5 by 1. So every integer, 5 is an integer, so 5 I can express 5 by 1 is a rational. So 5 is integer, so 5 by 1 is a rational number. So but converse is not true always. And one more, negative 8. So I can write negative 8 by 1. So is rational number because minus 8 by 1 or minus 8 both are same. So this is also a rational number because minus 8 and 1 both are integers as per the definition, numerator and denominator. Minus 8 and 1 are integers and denominator is non-zero, right? Here is a 1 is not equal to 0. That's it. So minus 8 is also a rational number, 5 also is rational number. So the rule is every integer is a rational number. But reverse means converse. Every rational number is need not be integer. So this one example you see. Okay, minus 5 by 3 is a rational number, but this is not an integer. Okay, and minus 4 by 7, or just you can take 6 by next any example 5. So these are all rational numbers, but these are not integers. Just obviously we can conclude one thing: every integer is a rational number, and every rational number is need not be integers. Because for example 7 you take, 7 is integer as well as it's a rational number. That means every integer is a rational numbers, right? And when you come to the next property, let us see about the 0. 0 is equals to 0 divided by 1. Same, 0 is equal to 0 divided by 5. 0 is equal to 0 divided by 6. 0 divided by any number other than 0 is equal to 0. So 0 is a rational number because numerator divided by denominator. Denominator is non-zero. In this 0 by 5 is nothing but 0. So 0 is a rational number. Just remember in this. So 0 is a rational number, right? So finally we conclude now every integer is a rational number. And next, the important one is every fraction is a rational number, but converse is not true. Every fraction. So what is the difference? What is fraction and a rational number? So rational number already we did both in p by q form. Fraction is p by q form. Rational number also is in p by q form. But is p and q or must be whole numbers? Only the positive. So p comma q are whole numbers, not negative. Here is a p comma q are integers. Okay, that is the difference. Integers means integers even there is a positive numbers also. So 2 by 3 is a fraction. Same 2 by 3 is a rational number, right? And minus 4 by 3. So is not fraction. But minus 4 by 3 is a rational number. Okay, there is a difference. Fraction is only the positive number, only if it is a positive or even 0. P, Q must be whole numbers. Then only it is a fraction. Then rational numbers is P and Q are integers. So every fraction is a obviously rational number, but every rational number is need not be fraction. So every fraction is a rational number, but the converse is not true. Okay, that's remember. And when you come to this one more property, let us see this positive and negative. For example, a rational number is said to be positive if the numerator and denominator both are positive or negative. both are positive or negative only, it's a positive rational number. So minus 4 by minus 3 or 4 by 3. If both are negative or both are positive, now it is a positive rational number. When this one is negative or one is positive, then it's a negative rational number. Numerator is negative, but denominator is positive. Or numerator is a positive or denominator is negative, is negative rational number. Right? Because minus divided by minus is the plus. You'll see in the next class also. So both are positive or both are negative, it is a positive rational number. Either numerator or denominator is negative, then it is a negative rational number. So these are the examples. Even minus 5 by 7. So it is a negative rational number. 8 by minus 11. Negative rational number. When it comes to the positive, minus 1 by minus 2. This is obviously 1 by 2 it is. Negative 4 by negative 3 is 4 by 3. But 5 by negative 5 by 7 or 8 by negative 11 or negative only. Okay, so one thing we can conclude here, minus 5 by 7 is exactly equals to 5 by minus 7 or minus 5 divided by 7. Anyway, it's printed in the book or when you notice in notebooks or textbooks, all are equal. Negative sign is for the numerator or denominator, or just in front of the number is the meaning is same. Okay, don't get confused about this. And let us see the one more last property in this. So every positive integer, that means every natural number, is also positive rational number. For example, just only take the number 5. 5 by 1 is a positive natural number. So every positive integer is a positive rational number. And every negative integer is a negative rational number, obviously. Every negative integers are minus 4 is a negative integer. So this is the negative rational number. That means every positive integer is a positive rational number. Every negative integer is negative rational number. So 0 is the rational number, but it's neither positive or negative. It's important. 0 is a rational number, but it is not positive, neither positive or negative. Okay, these are the cases we'll apply in this and make into simplest form. For example, negative 10 by 8. So we need to write in simplest form any number. 10 and 8 are in even numbers. We can cancel straight away. 2 5s are 10, 2 4s are 8. So negative 5 by 4. So negative 10 by 8 is obviously equals to negative 5 by 4. With any table you can cancel even in this. And for example, if the two rational numbers are equal, for example, x by 4 is equals to minus 6 by 3. Then to find out the value of x, just to do cross multiplication. 3 into x is equals to 4 into negative 6. Okay, 3x is equals to negative 24. Then x value is negative 24 divided by 3. That is negative 8. Because we can cancel this. 3 tables, 3 ones are 3 8s. Don't worry about sign. Same negative sign we apply here. So whenever two rational numbers are equal with numerator and denominator both the sides, just go for cross multiplication and solve. Right? These are the important properties from this rational numbers. Mostly from this, based on properties only, we can need to solve the problems also. Let us see how to representation of rational numbers on number line. Representation of rational numbers on the number line. So we have 2-3 methods. So one simple technique we'll see how to represent any rational number on the number line. Okay, for example, let us take one question. Represent 1 by 2. Let us take for example 1 by 2 minus 3 by 2 and minus 5 by 3, 4 divided by 3 on a number line. So if you get the questions like this to represent on the number line, so first we know how to represent the integers on the number line, right? Already if you draw the line, first of all we need to mark the 0 at the center, and from this, so right side is positive values 1 2 3 so on, and left side is minus 1 minus 2 minus 3 so on, so till infinity this side, and LHS and right side and left side. Now in this, we to represent this particular number, for example 1 by 2 or minus 3 by 2. So based on the denominator, we can take the step. For example, first question is 1 by 2. So it is the denominator is 2. Because of denominator is 2, in 0, 1, 1, 2, 2, 3, this is the 1, 1 unit. Okay, let it be, this is the O and is A, B, C, so on. This is the A dash, B dash, C dash, so on. That means C dash to B dash exactly equals to B dash A dash equals to A dash to O, that is equals to OA, and AB is equals to BC, so on. That means distance between every point to point, integer points are equal. Now to represent fractions or rational numbers, to represent on the number line, according to denominator we have to take the step. First problem, denominator is 2, right? So between 0, 1, 1, 2, 2, 3, we should make into two parts. Okay, let us see here. Let me take one more. Now this is the number line. Center is 0 and it says 1, 2, 3. Maintain the same distance by using the scale. So to represent 1 by 2 minus 3 by 2, first one 1 by 2. Denominator is 2, right? So because of the denominator is 2, between 0 to 1 we have to make into two parts. 1. So this is a 1, 2 parts. Again here. So between every number make into two equal parts. To represent is 1 by 2 now from the 0 right side because of the positive value it is. From the 0, then numerator is 1. 1 means the first point. So the first point is 1 by 2. So this is 1 by 2 now. Okay, exactly. You can write the top. This is exactly equals to 1 by 2. This number. And see the next one, minus 3 by 2. So minus 3 by 2 is a negative one. This also denominator is 2, right? So between every point, 0 to 1, 1 to 2, 2 to 3, according to the denominator, that many parts you do it first. So already two parts are done. Now numerator is minus 3. Minus 3 means from the 0, left side 3 points. So till here is 1, 2, 3. Now this is minus 3 by 2, right? This point is minus 3 by 2. And third, fourth questions you observe once. Minus 5 by 3 and 4 by 3. Denominator is 3 now. Okay, this right side I am doing. So what we should do, first of all, we should take the number line. In this number line represent 0. And here we can take this 1, 2, and this left side minus 1, minus 2, so on, right? So because of denominator is 3, we need to make 3 equal parts between every point to point. Between 0 and 1, 3 equal parts. So right, so 1, 2, 3, 3 gaps exactly. 2 lines if we can make, 3 parts will come. Same here also 1, 2. Just you can 3 equal parts you can make between 0, 1, 1, 2 or minus 1, minus 2, 0 to minus 1. Now based on the according to the denominator we should make the parts. Now according to the numerator we should find out the point position. Because of minus 5 it is, right? So from the 0 we should go for the left side. So 1, 2, 3, 4, 5. Fifth place. So this is the position. This is minus 5 by 3. Next one is the last one is 4 by 3. Same, because of denominator is 3 equal parts are done and numerator is 4. Okay, numerator is 4. From the 0 right side 4 parts, fourth line. Don't say this 1, 2, 3 now. So this is the first line, second, third, 4. This is right. This is the 4 by 3. Okay, this is the way. This is one of the simple way. Whenever based on the denominator, you can make into parts. According to the numerator, find the position of that number. Okay, so this is the way we can represent any number, any fraction or rational number on the number line. Comparing rational numbers. So here we can notice three important things. First one, every positive rational number is greater than 0, right? If you see 8 is greater than 0. Every positive rational number is greater than 0 and is greater than every negative number also. Even 8 is greater than minus 93, or even 8 is greater than any negative number, 1264. So this is the one rule, remember. So to compare the rational numbers, so three rules remember. And one more, every negative rational number is less than 0 and less than every positive number, right? Minus 8, so that is less than 0, or negative 8 is less than 5, and same negative 8 is less than 123, so on. So all the negative numbers are less than 0 and even positive numbers are greater than 0, and so this is the rule. And 0 is greater than every negative numbers, even when you come to the 0. So 0 is always greater than all the negative numbers. 0 is greater than minus 8. 0 is greater than minus 3 by 20. Any negative number you can take. So 0 is greater than negative. Same 0 is, but 0 is less than positive numbers. And 0 is less than any positive. 0 is greater than negative, 0 is less than positive. So etc. And based on this we can compare the rational numbers. Let us take one example. So compare 3 by 5 and 5 by 7. Okay, or 3 by 5 minus 3 by 5. 3 by 5 and negative 3 by 5. So directly we can say these type of questions. Always positive number is greater than, right? So 3 by 5 is greater than negative 3 by 5. That's it. So therefore 3 by 5 is greater than this negative. Directly we can say. So negative numbers are lesser than the positive numbers. And in case if the questions are both are positive, like compare same 3 by 5 and 5 by 7. Okay, so both are positive numbers. Then we need to make the first rule is we should make the denominator must be same. So the one of the method is take the LCM of denominators, that is 5 comma 7. 5 comma 7 LCM is equal to 35. Okay, LCM already learned previous classes. The least common multiple is of denominators of 5 7 is 35. So we should make the denominators must be 35. 3 by 5 is one number and 5 by 7 is another. So we should frame the denominators must be equal to LCM 35. So to make it as denominator as 35, 5 into 7 is 35. Same 7 you multiply and divide. Here is 7 into dash is 35. 5s are, right? Same 5 multiply with numerator. So 3, now 3 by 5 into 7 by 7. So 3 sevens are 21 by 35 and 5 5s are 25 by same 35. So the value is same. Okay, this 3 by 5 value exactly equals to 21 by 35. Same 5 by 7 value is equals to 25 by 35. Now when the denominators are same, then by observing the numerators, we can say which is greater, which is small. So 21 is less than 25. That means 25 by 35 is greater than 21 by 35. But 25 by 35 is 5 by 7. Right? So therefore 5 by 7 is greater than 3 by 5. So we can compare in this way. So not only two fractions, if it is more than 2 also. Let us take one example. Find write in ascending order or descending order. So arrange, let us take one question. Arrange minus 9 by 10, 7 by minus 8 and negative 3 by 4 in ascending order. This we need to make in ascending order. Ascending order is the small to big. So we need to find out which is the small in this. So all are negative numbers, right? There is no any change. That means minus 9 by 10 comma same negative 7 by 8. 7 by negative 8 or negative 7 by 8, both are same. And one more is 3 by 4. First of all, we need to take the LCM of the denominators. So LCM of this 10, 8, 4. 10, 8, 4 you can do LCM. LCM method already know is 2 5s are 4, 2. Right, again 2 table 5, 2, 1 is 10, 40. So LCM is equals to 40. Now we should frame the denominators must be 40. All the denominators. Already it is 10. So we should multiply with 4 by 4 because 10 4s are 40. It is already denominator is 8. So 5 by 5. And this is already 4. 10 divided by 10. Same whatever number you multiply with the denominator place. Same we can multiply for the numerator. Now minus 9 into 4. So minus 36 by 40. And this is minus 35 by 40. And this is minus 30 by 40. Okay, these are the three. But we already know since negative 36 is less than negative 35 is less than negative 30. Because negative numbers, negative 36 is leftmost place. This is less. So if it is less, therefore same negative 36 by 40 is less than, same negative 35 by 40 is less than negative 30 by 40. Yes. So from this, according to the question, we can make. Therefore, negative 36 by 40 is negative 9 by 10. So minus 9 by 10 is less. Next one is 7 by minus 8 is less. Next to the minus 30 by 40 is negative 3 by 4. Accurately got according to the given also. So this is in order because why you took minus 36 minus 35 means on the number line if you observe. So 0, this side is minus 1. So on if you take next to minus 30, then minus 35, minus 36. So minus 36 is less than negative 35 less than negative 30. So on this side is a positive and out, right? Okay, so this is the way we can compare any number, not only 2 or 3 fractions or 3 rational numbers. Any numbers are given, we can do the comparing. Okay, let us see the problems on rational numbers, even of additions also now. Addition of rational numbers. So like we are adding integers, whole numbers, natural numbers. Even when you come to this rational numbers, we need to apply two rules. When the denominators are same, we can apply one method. When denominators are not equal, we'll apply one more. Let us take one example when denominators are same. Denominators are same means, for example, 4 divided by 15 plus 8 divided by 15. So whenever denominators are same, 4 by 15 is a rational number, 8 by 15 is rational number. If denominators are same, we'll add only directly the numerators. That is 4 plus 8 and same denominator, 15. This is the method. 4 plus 8 is 12 by 15. Okay, not to confuse. Keeping the denominator same, just add the numerators. Okay, remember. And one more, same, not only positive, even negative also. Like negative 4 by 15 plus 8 by negative 15. Yeah. So this we can make into same denominator. That means already it's same. 4 by 15 minus 4 by 15 plus 8 by negative 15 is negative 8 by 15 also same. So denominator is same, directly you can write, and according to the numerators, negative 4 plus minus 8. So negative 4 plus of negative 8. Negative 4 plus negative 8 is here, yeah, negative 12 by 15. Minus 4 minus 8 is minus 12. So minus 12 by 15. And if required, express the rational numbers obtained in its lowest terms. When after simplifying, you must make into lowest terms. First example is 12 by 15. So both you can cancel in 3 table. 3 4s are 12, 3 5s are 15. Same table you can cancel on numerator and denominator. So 4 by 15. This is same negative 4 by 5. Yeah, 4 by 5, this negative 4 by 5. This is the case when denominators are same. And case 2 is if denominators are not same, what we should do. For example, minus 2 by 3 plus 3 by 4. Just only simple rule is we should make the denominators must be same. For that, just to go for the LCM. So take the denominators 3, 4. Find out the LCM. Okay, it's already 4 directly. So 3 comma 4 LCM is 12. Now we should make the denominator as 12. So negative 2 by 3 plus 3 by 4. We should make it as denominator must be 12. So same number we can multiply and divide. So this multiply with 4 by 4 because 3 4s are 12. Next up we'll get. Same 4 should multiply for the numerators. Same how we did comparing numbers no previous topic. Same as this. This is for 3 by 3 because 4 3s are 12. Same number should be multiplied on numerator also. So value does not change. So minus 2 into 4 is minus 8 by 12 plus 3 3 is a 9 by 12. Right? Now same like previous. Whenever the denominators are same, how we did? We just add the numerators. Minus 8 plus 9. Already we learn in integers. Minus 8 plus 9 is 1. So 1 over 12. Okay, this is the way we can apply even the addition of rational numbers when denominators are not same. Let us take one more example. Okay, same 9 over minus 16 plus minus 5 by minus 12. Let us take. Already according to the properties, 9 by negative 16 is minus 9 by 16 we can write. Plus minus 5 by minus 12 is just 5 by 12. You can use the properties when both are negative, numerator and denominator is negative. It is a positive rational number, right? According to the properties. Now for the 16 and 12, just to take the LCM. 4 4s are 4 3s are. Just 4 into 3, 12, 12 4s are. So 48 is the LCM for this. Now we need to make it as 48. So minus 9 by 16 plus 5 by 12, right, as it is. Now just you can to make the denominator as 48, you check. This is 4 by 4 because 12 4s are 48. And here is a 3 by 3 because 16 3 is a 48. Just now you can simplify, you'll get minus 9 into 3 is minus 27 by 48 plus 5 4s are 20 by 48. Whenever the denominator is same, minus 27 plus 8, just add the numerators. Minus 27 plus 20 is minus 7 by 48. And minus 7 by 48 we can't simplest form more because there is no common table. If there is any common table, you can write in simplest form. So not only the two fractions, if it's more than two rational numbers also, we'll apply the same. Just you can make the denominator same, then directly add the numerators or subtract the numerators according to the symbol. Okay, this is what we can do addition. Same concept even you can do in subtractions also. Let us see. Subtraction of rational numbers. We can do how we did addition of the rational numbers. Same concept will apply even for subtraction, right? For example, if you see the integers 8 and 5 are the two integers, you know, right? When you want to do subtraction 8 and 5, in between you will keep the negative sign. So that is 8 minus 5 is equal to 3. So same way, even in the fractions like rational numbers, we can use the same concept. For example, 5 by 6 is one rational number and 3 by 4. So you want to subtract 5 by 6. So 3 by 4 from 5 by 6 we need to subtract. So is 5 by 6 minus 3 divided by 4. So if the question subtraction of 3 by 4 from 5 by 6. So from 5 by 6 only this 3 by 4 you are subtracting. Here also same. We subtracted 5 from 8. That's why 8 minus 5. So when you do the same process but the sign is negative sign in between. So 6 and 4 LCM is 12. So 5 by 6 same minus 3 by 4. So because of LCM is for denominator 6 and 4 LCM. For 6 comma 4 least common multiple find out, because based on that we can find out what number should be multiply and divide. So 2 3s are 6, 2 2s are 4. For 3 and 2 there is no common factor, directly can multiply these 3. 2 3s are 6, 6 2s are 12. So 12 is LCM. So that's why you should multiply 2 by 2, because 6 into 2 is 12. Same number you should multiply for the numerator. Same how we did the concept in additions. Here is a 3 by 3 because 4 3s are 12. Right now 5 2s are 10 by 12 minus 3 3s are 9 by 12. When denominators are same, directly you can subtract the numerators. 10 minus 9, that is 1 divided by 12. Okay, so this is the one way. Let us see few more problems on this subtraction of rational numbers using this word problems also. So the question is subtraction of, or subtract minus 5 by 8 from minus 7 by 12. Okay, so this is the problem. Subtraction of minus 5 by 8 from minus 7 by 12. So they said from this, from minus 7 by 12. So from minus 7 by 12, what we have to subtract? We need to subtract minus 5 by 8. Minus 5 by 8 we have to subtract. So because of subtraction, we need to keep the negative sign in between. That's why whenever the both are negative, you should be careful and maintain the bracket for the first step. Okay, subtraction of minus 5 by 8 from minus 7 by 12. So minus 7 by 12 is as it is. Minus of this we have to subtract. This is already negative number. So minus 5 by 8. Now we can directly use the formula minus 7 by 12. So minus into minus is plus 5 by 8. Okay, minus into minus is plus, formulas you know. And for 12 and 8 LCM we calculate. LCM of 12 comma 8. So that is 24 will get, right? Already we did previous. 12 comma 8. 2 table, 6 4. Again 2, 3, 2. 2 is a 4, 4 3 is a 12, 12 2 is a 24. So to make this as 24, minus 7 by 12 plus 5 by 8. So to make this as 24 as LCM, 2 by 2, this is a 3 by 3. That we should know clearly to do the subtraction. And minus 7 into 2, minus 14 by 24 plus 5 3 is a 15 by 24. So 24 is a LCM now. Same denominator, minus 14 plus 15, that is 1 by 24. Right, 1 by 24 is the answer for subtraction of just minus 5 by 8 from minus 7 by 12 is this. So this is the way we can do. And let us see one more question on this word problems only. For example, what should be added? Okay, the question is what should be added to minus 3 by 8 to get 5 by 6. Okay, what is supposed to add to minus 3 by 8 to get 5 by 6? So this we can let it be in the system in word format to the sentence. Let x be added. Okay, what should be added means, let I am taking some, there is a number, there is a rational number is x. X should be added to get 5 by 6. Then we can write like this. Minus 3 by 8. What should be added to minus 3 by 8, right? So minus 3 by 8 plus what we should add? I should add, supposed to add x to get. So what we should get by adding this is supposed to get 5 by 6. Now this is the method to directly exactly either subtraction of these both or 5 by 6 or minus 3 by 8. What we have to subtract to understand clearly? You assume some letter a or x should be added or should be subtracted. Those type of questions. So plus x I do. Now using this, x is equals to minus 3 by 8. Take right side, that becomes plus 3 by 8. Okay, transposing. That means the answer is 5 by 6 plus 3 by 8. Okay, for again same method. Just for 5 by 6 plus 3 by 8. So we should go for LCM. 6 and 8 is LCM is same 24. So 4 by 4 and this is 3 by 3. Method is same, right? 5 into 4, 20 by 24 plus 9 by 24. You already know this, 29 by 24. And if you convert into this mixed fraction, 1 5 by 24 is answer. So what should be added? Similarly, what should be subtracted to from this to get same? Let be x should be subtracted. Then minus x you keep. Based on that, you can convert the question in order, then find out that particular x value. That only is the final answer for us. Okay, these are the type of questions they'll ask based on this rational numbers about subtractions. Multiplication of rational numbers. So when you come to this multiplication, it's very simple. Instead of taking LCM like addition and subtractions, directly we can do multiply numerators and denominators separately. So when you come to this multiplication or product, multiplication, or we can say it's a product. Okay, so these are the two words. Product also is a multiplication of two rational numbers. If you want to multiply any two rational numbers, so the simple technique is just we can take that product of their numerators, multiplication or product, right? So product of their numerators. So numerators you need to multiply and divide by same product of their denominators. So this rule we can apply to the multiply any two rational numbers. Simple. So if a by b and c by d are the two rational numbers. So if you want to multiply this, then the product is, or multiplicand, directly we can write a into c by b into d. Okay, if these two are the rational numbers, then product is a into c by b into d. Let's have some example questions they can understand clearly. For example, 2 by 5 is a number multiplied with 3 by 4. So if you want to multiply this directly, the product of their numerators, right? So 2 into 3 divided by 5 into 4. Both the numerators are 2 and 3 is in numerator place. Now 2 into 3 is 6, 5 into 4 is 20. So 2 by 5 into 3 by 4 is equal to 6 by 20. To write in standard form, we can simplify this. 6 by 20 is a rational number. But to make this in standard form, you simplify. Okay, same table you can cancel with numerator and denominator. 2 table, right? 2 3s are 6, 2 10s are, because both are even numbers. 3 by 10. So 3 by 10 is a rational number and there is no any common factor for numerator and denominator. So this is the standard form of rational number. So 2 by 5 into 3 by 4 is equal to 3 by 10. And whenever the negatives and positive numbers, we should be careful while doing. For example, minus 3 by 5 into 4 by 7. So you need to multiply this with the simple formula is any negative number minus into plus. It's a minus. Plus into minus also is minus. Only both are positive, will get positive, or both are negative, will also get positive. Okay, here is one is negative, one is positive, will get again the negative only. Both are plus or both are minus, will get again positive. So here is a 3 by 5 is the negative integer, 4 by 7 is the positive. So result is minus into plus is overall minus it is. Now the numerators 3 into 4 by 5 into 7. So all this is negative number. Now 3 into 4 is 12 by 5 into 7 is 35. So minus 12 by 35 is the answer. And similarly, when both are negative, like minus 15 by 8 is one rational number, and minus 4 by 5 another rational number. So we need to multiply this. First you need to multiply the sign. Sign means you can use this rule. So when both are plus or both are negative or one is positive or negative, you can check. 15 by 8 is the negative, 4 by 5 is also negative. Minus into minus is plus. So in general, plus sign need not to keep. Just you can understanding I am keeping. And numerators is 15 and 4. Don't take again minus 15 and minus 4 because already I multiplied this sign. Okay, minus into minus is plus. Now 15 into 4 numerators, 8 into 5 denominator. 15 into 4 60, 8 into 5 is 40. So both we can cancel with its 10 table directly. 10 6 is 60, 10 4 is 40. 6 divided by 4 again with the 2 table, right? 2 3 is 6, 2 2 is 4. So 3 by 2 is the standard form. 3 by 2 is the answer of minus 15 by 8 into minus 4 by 5. This is the simple method you can apply. Sign negatives, sign you can multiply first. Or else even if you write minus 15 into minus 4 also, next step will become plus 60 only. Okay, in case if you want to write like minus 15 into minus 4, obviously next step it becomes minus to minus plus. Directly also you can do, or else by substituting also you can make it. Okay, so this is the multiplication of rational numbers. So direct to simple formula. To multiply two rational numbers or more than two also same. Just product of their numerators divided by product of their denominators. Division of rational numbers. So let us see this topic now. So actually the multiplication of rational numbers we checked, right? Now division is nothing but this is the inverse of multiplication. So let us see what is this division and how to do, and we'll continue the properties also in this. So this is the inverse of multiplication. So for example, if a by b is a one rational number and c by d are two rational numbers. These two are the two rational numbers. Then, so how to divide this? And here is the c by d. The second rational number is not equal to 0. That is the rule. A by b and c by d are two rational numbers, and the second one c by d is non-zero. Then if you want to divide this, a by b divided by c by d. Okay, there is one rational number divided by another rational number. That we can write a by b is as it is, divide by c by d, right? So if we keep multiplication symbol, now that is nothing but a reciprocal of c by d. So we can take this reciprocal of c by d. So that is equals to a by b into c by d reciprocal is d by c. Whenever instead of divide by symbol if we keep into symbol, then next fraction should be reciprocal. That is a d by c. So this is nothing but ad by bc. Right. So here is the c by d. If it is 0, what will happen? Then a by b divided by 0. So it's undefined. Right. Division by 0 is not defined. There's a rule. And anything we want to divide the same. Let us see with examples. Just only the inverse of multiplication. Remember that. So 3 by 4 is one number divided by 5 by 12. Okay, so 3 by 4 divided by 5 by 12. 3 by 4 is a fraction. So we can write now 3 by 4 as it is. The division symbol you must keep it as into, then 5 by 12 reciprocal. That is 12 by 5. Then normal, now we can continue the multiplication process. So 3 into 12. We did in the multiplication of rational numbers, right? So okay, the product of their numerators by product of their denominators. Same will apply here. 3, 12, 36, 4 into 5, 20. You can write in standard form, make into simplest form. This is the 10, 18, 2 table. Again 2 5s are 10, 2 9s are. So 9 divided by 5 is the answer of 3 by 4 divided by 5 by 12. Let us see why we need to do like this. Now just for if we check this, actually this is a by b divided by c by d, right? A by b divided by c by d we can write. Now any denominator is a fraction. If we take to numerator place, that will be reciprocal. That means a by b into this c by d is denominator. If we take up, it will become d by c. Okay, same logic, same concept we applied in this. Instead of writing like divided by c by d and all, just we can write into symbol. And second fraction, the second rational number should be a reciprocal. Just there's a small change in this. So any examples also be same, right? And for example, minus 6 by 7 divided by 4 by 21. Okay, so what we should write here? Minus 6 by 7 divided by symbol 4 by 7, 4 by 21. Now after writing this, next first fraction or first rational number as it is, should not change this. Whenever you keep the into symbol, then reverse means division is a reverse of multiplication. So division symbol if you keep into, next immediately this 4 by 21 you can write 21 by 4, reciprocal of that. And now you can directly normal multiplication process we can apply. Minus 6 into 21 by 7 into 4. Yes, just you can simplify. If you instead of multiplication you can simplify like this also. 6 and 4, 2 2s are 2 3s are, and 7 1s are 7 3s are. Directly also you can multiply. Minus is there, 9, 3 into 3 is 9, divide by 2. Minus 9 by 2 is answer, right? Let us have one more example with negative sign. Same thing we need to apply. This is the division of two rational numbers we are doing. For example, minus 16 by 17, or else take 27. Minus 16 by 27 divided by minus 8 by 9. So here is same, minus 16 by 27 into this minus 8 by 9, 9 by minus 8. We can write. And 16 by 27 is a negative rational number, 9 by 8 also negative rational number. There is no difference between minus 8 by 9 or 8 by minus 9, just whatever it is, previous topics we discussed. Negative sign is for be numerator or denominator or in between also, there is the same negative only. Now minus into minus is plus. We can cancel here. 9 ones are 9 threes are, and 8 ones are 8 twos are. So finally 2 by 3, and minus into minus is plus, already we know. Same, when the both are negative numbers, if you multiply you get the positive. Both are positive also positive, only when the one is negative and one is the positive, then you get the negative number. Right? This is the simple concept of the division of rational numbers.